Okay, so today we're going to be looking at topic two, which is to do with computer organization. So, looking at the CPU, this is the computer architecture. Here we can see a little overview of the structure of the CPU. So that's the ALU, MAR, MDR, CU, control bus, and yeah, you can see all that. We'll explain what they are on the next slide. So the ALU is mainly used for performing mathematical and logical operations on data. The MAR holds the address of the memory location to be accessed. The control unit, MAR stands for memory address unit, and ALU is algorithmic logic unit, by the way. CU is the control unit. It coordinates and controls the activities of the CPU components. The cache temporarily stores frequently accessed data for faster retrieval. The address bus transmits memory addressed from the CPU to other components. The memory bus facilitates data transfer between the CPU and memory, and the control bus manages control signals for coordinating and synchronizing activities within the CPU. So looking at primary memory, also known as RAM, we can see that it's a volatile computer memory, which means that it temporarily stores activity of running programs. And it's volatile because once the computer is powered off, it will wipe itself of all the data it was storing while the computer was running. It provides fast read and write access during computer operation, and it's utilized by the operating system and applications for quick access to data. So the Mastruni instruction cycle includes three things, which is fetch, decode, and execute. So during the fetching cycle, the CPU will retrieve the next instruction from memory, copy it into the instruction register, and then decoding, you interpret the instruction to determine the required operation, and then executing is performing the operation or calculation specified by the instruction. Secondary memory, the reason why persistent storage is important is so that it holds data even if there is no power. Examples of persistent storage include HDD, which is magnetic, SSD, which is electric, and CDs, which are optical. HDD stands for hard disk drive, SSD stands for solid state drive, and they are needed so that users can retain file information for tasks that they are doing on their computer, even once they shut down their computer. The operating system has many main functions, a few of which are listed below. So it's needed to provide user interface, which is normally in the form of a graphical user interface. However, some older operating systems use command line interfaces, which allow for a link between the users and the computer hardware so they can interact with the computer hardware and use it. Then there's memory management, which is how the operating system controls RAM being allocated to running programs so they run efficiently. Peripheral management, the OS has device drivers which allow hardware to interact with the operating system. Multitasking is to do with the coordination of allocating CPU time for each program. And then there's providing security, which prevents unauthorized access and protects files. So application software, some of the common ones include word processors, spreadsheets, data management systems, email clients, web browsers, computer-aided design, and graphics processing units. So word processors are good for storing, manipulating, and formatting text from the keyboard, and then they display that on the screen. Spreadsheets arrange data in columns and rows for calculations. Database management systems create, receive, update, and manage data for users. Email clients access, compose, and manage users' email. Web browsers retrieve, present, and traverse information on the internet. And CAD is useful for assisting in designing models. And graphical processing software is good for image editing. So the common features of application software include a toolbar, menus, dialog boxes, and GUI components. Binary representation. So we have a bit, which is the smallest unit of data in the computer, and is comprised of a 1 or a 0. And then there's a byte, which consists of 8 bits. Binary is a base 2 numbering system used by computers to hold and process data in the form of ones and zeros. Denary, or decimal, is what we use in our everyday life. It's also known as base 10 numbering. Hexadecimal is base 16 numbering, which is used to represent large numbers quickly, and it's very often used in color representation within computers. So how is data represented? So there's strings, integers, floats, characters, ASCII and Unicode for characters, and colors which are often represented in hexadecimal. So a character is a single letter. A string is sequential letters. Integers are whole numbers. Floats are decimal numbers. And then, like I said earlier, colors are stored in hexadecimal values. So Boolean operators are AND, which is if both inputs are 1, output 1. There's OR, if either or both inputs are 1, output 1. Not, output the opposite of the input. NAND, which outputs the opposite of what the AND operator would output. NOR, which outputs the opposite of the OR operator, so outputs the opposite of what this would output. And then XOR, which is exclusive OR, which is if only one of the inputs is 1, output 1. So if A and B were both 1, then it would not output 1. It would have to be A is 1 and B is 0, or A is 0 and B is 1 to output 1. So a quick question is to construct a truth table from this here. Basically, to explain this, we can see here. So it's x is equal to a's exclusive or b, y is equal to a not or c, and z is equal to x or not y. So here we have all the combinations 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So for x, obviously that's just the way you can go through systematically going through every single combination of a, b, and c with zeros and ones. So for x, we have a exclusive or b. So this is if a or b only are a 1, then output 1 here. If they're both 1, don't output it here. So 0, 0, 0, 0, 0, 0, 0, 1, there's only 1, 1, so we output 1. 0, 1, there's only 1, 1, so we output 1. 1 or 0, there's only 1, 1, so we output 1. 1, 0, only 1, 1, output 1. 1, 1, and 1, 1. So both of these have 2 1s. So this is where exclusive OR comes in, and you don't output a 1 if both are 1. It's only if either one of them are 1 by themselves and the other is 0. So for y, we have a not or c. So that's basically a or c and the opposite of what that would give. So if you're looking at a or c, neither of them are a 1. So you'd output 0 if you're using or, and the opposite of that is 1. Same here, 0, 1 opposite is 0, 0, 0 opposite is 1. 0 and 1 opposite is 0. Anything that includes a 1 basically is 0, and anything that is purely 0 outputs a 1. So that's why the rest of these are zeros. Then Z uses X and Y here. So X or not Y. So if either one of them are a 1, then output 1 here. But we can see not Y times this is 0, so it's 0, 0, 0, 0, 0, 1, 1, 0, 0, and that's just an explanation of that. All of these go to 1. And then logic gates. So a quick question is to construct a logic diagram for the Boolean expression of not A or B and C. So here we see it's not A or B and C. Now and comes before all of these. So the reason why it's not an A and then or B and then you put and C at the end is because these two and has to go first. So B and C, not A, they go into the or operator and then they output that. And yeah, that's the end of it. Thanks.